Hello everyone. In chapter 6, we learn how to manage project schedule. Developing a good project schedule is critical because it communicates the major activities and milestones of the project with its key stakeholders. Also, project schedule is one of the key baselines that is used to for assessing the performance of a project. Our learning objectives for this chapter is for you to be able to discuss project scheduling, its importance, and its challenges, as well as be able to describe scheduling techniques, describe the project management software and how they can help you with development and presentation of the project schedule. So many projects suffer from schedule delays, especially in the field of IT. I'm sure you have heard and read about many project disasters associated with schedule. But the case that was included in the textbook is actually a successful implementation of a touchless electronic ticket system in the London subway and bus system. This modernization project has enabled the system to optimize its routing and scheduling of the buses and trains based on the rider information that they collect and is readily available to management. So one of the things they did in this challenging project, which was bringing some very new technology to a very aging system, they decided to take the approach of slow rollout instead of a big bang approach. Big bang approach would be if they implemented this system throughout the subway and bus system overnight or over a weekend, but they found that to be very risky, and they chose an approach based on a slow rollout. So they chose various, starting with small stations and moving on to larger ones. And they even chose to pilot the system in a mock-up train station. When I was at US course, many of our projects had to be implemented for many different courts throughout the country. And because of that, we also chose the slow rollout kind of waves of implementation, so we would minimize the risk by knowing if there are any problems. We would know those problems in smaller scale, in fewer courts, and we deal with those quickly rather than impacting the entire system. We usually develop the first version of the project schedule during the initiation phase to assess the feasibility of the project. As we proceed with planning, we further detail out the schedule as we develop a better understanding of the work involved. The schedule that we have at the end of the planning phase is not perfect, but nevertheless it serves as the baseline for controlling the activities during the project execution to know if we are ahead of various milestones or if we are behind them. And if we are behind certain milestones, we develop actions to get caught up with delayed activities. In a survey of business analysts, these are the challenges that they identified with IT project management. And when you look at this list, a good project management, schedule management can address a number of these challenges. For example, if you have a good schedule, the schedule helps to clarify the scope of the project, the major milestones of the project, to communicate that with the project team and the project sponsor. Also, in a situation when the organization's priorities are changed and the resources to the project are reduced, then the project schedule can serve as a communication tool to communicate what the impact of reduced resources would be on the project. PMBOK, Project Management Body of Knowledge, which we have discussed before, it's published by Project Management Institute, details the project schedule management into a number of sub-processes. Planned schedule management is basically the planning of the whole schedule management and how we are going to manage it. And then part of that plan, or a number of things that happen in that plan, we need to define activities required for completing the project. We need to sequence those activities in a logical and an optimal way. We need to estimate each activity's duration and then combine all that information to develop a project schedule. You use the baseline schedule from then on to control execution of all the subsequent activities. So how do we define activities? One of the most effective ways is by breaking down a project to smaller pieces. The outcome of this process is called work breakdown structure, or WBS. Each smaller piece is called a work package. We continue the breakdown until the activities required for each package can be clearly identified. Generally, we need to break down the project into small enough pieces that are not longer than 80 hours and preferably actually not longer than 40 hours. By doing that, then each activity can be well managed and not impact other activities in our project. The process of breaking down a project is called decomposition and can be done in two ways. We can use a top-down approach, which is really looking at the project from the top and identifying the major pieces or major phases of the project, and then from them break it down further. Or we can do the project bottoms up, and that would mean that we involve more people who are familiar with various aspects of the project and can be more, this approach can be more time consuming. but at the same time can produce more detailed project schedule. Regardless of which method we use, the component of WBS is called a WBS dictionary, which will include the details for each of those components. The scope statement, which we discussed in the previous chapter, along with the WBS and its dictionary, will then serve as the scope baseline for the project. And again, the scope baseline will be used to control the scope during execution. So let's look at some examples of how we can break down a project. This is a simple remodeling project, and as you can see, there are a number of activities that we anticipate for this project. We research various remodeling ideas, and we establish a budget for our project. Then we hire a designer to come up with the plan for remodeling within the budget that we have in place. Then we take that design and execute it, and we remove the old furniture and carpet, and we paint the wall and lay the new carpet, and then we bring the new furniture in. So these could be the major pieces of a remodeling project. We can also decompose a product similar to a project. When we look at the product breakdown structure, in this example, we are doing that for a personal computer, and there is we can break it down into the main unit and the monitor. And then, of course, each of those can be further broken down into housing, motherboard, CPU, and all that for the main unit, and housing and OLED unit and printed circuits and so forth for the monitor. So this is a product breakdown structure. One of the ways of doing the breakdown, a top-down approach for breakdown, is breaking down the project based on its phases. This example, we are breaking down the project based on the phases of a system development lifecycle, and the activities in this example are further grouped into pre-project activities and then post or project specific activities. So this is before authorization and after authorization of the project in many systems. Another way to break down a project is through its functionality. As shown in this example, when we look at an enterprise resource management system and a ERP system, it may have the accounting module, the finance module, HR module, and so forth. And each of these modules can further be broken down into sub-functionalities, so that's another way of doing the WBS. In Microsoft Project, you can create activities and sub-activities as you decompose the project and basically set up the WBS in Microsoft Project very easily. PMBOK establishes an input and an output for each project management process. So in this particular slide, we are looking at the define activity process. This process uses the scope baseline and schedule management plan, as well as considering the organizational factors and organizational process, and produces a list of activities and their attributes, such as their duration, the resources that they require, and produces a list of milestones for the project and the baseline for the schedule and cost. So it's extremely important to make sure that a project WBS, the list of activities and their attributes, are as complete and as accurate as possible. The process itself includes decomposition that we already discussed. It can also involve in getting the opinion of the experts to help us to identify activities and their attributes. One of the techniques that is used for doing this is called rolling wave planning, as shown in the next slide. In rolling wave planning approach, we reiterate the decomposition process with the primary focus on the tasks that are coming up, rather than the tasks that are later in the project. The future components will then be broken down in the future iterations. So as we move further and further on the project, we keep decomposing the activities that are closest to us. As we go through more iterations of the work breakdown structure, our level of uncertainty is reduced, because as we move on the project, more details about the project is known, as shown on this graph. In many organizations, they require that the project team at least develop a rough order of magnitude estimate, or a ROM estimate, by the end of the feasibility phase. This estimate can be overrun by 75% or underrun by 25%. So that's the level of accuracy for that estimate. For approving the project budget, many organizations require a better quality estimate. They call that budgetary estimate, which would have the accuracy of plus 25% to minus 10%. As the project progresses, during the execution of the project, the project team can develop a definitive estimate with the accuracy of plus 10% to minus 5% accuracy. This estimate is, the definitive estimates are typically developed for the management to decide if they are able to release part of the project budget or do they need more time and more money. Another process that we use for managing project schedule is sequence activities process. So this process uses the output of the define activity process that we just talked about and produces the project schedule and the network diagram. To sequence activities, we use a precedence diagramming method to determine or to show the dependency of tasks, as well as the leads and lags that may be associated with various activities. We use a scheduling software like Microsoft Project to prepare project schedule and network diagram. So let's take a closer look at methods and techniques we use in the sequence activities process. Precedence diagramming method simply connects various activities in a project. In this example, activity D has to happen after activities A and B. At the same time, activity E and the end of the project cannot occur before activity D is completed. When we want to sequence activities, we may encounter 4 different types of dependencies. The most common dependency is finish to start. Task A has to be finished before task B is started. For example, programming language needs to be chosen before programming can start. Another dependency is start to start. Task B can't start until task A started. Programming can start when program design has started. Usually there is a delay so that we can get some basic design done before programming starts. Another dependency is finish to finish relationship, is when B cannot finish until A is finished. Testing cannot finish until programming is finished. Again, typically with a little bit of delay. The last type of dependency and the rarest form of dependency is start to finish, where task A can't start until task B is finished. For example, saving a copy of the program cannot start until programming has started and some code is in place. This is a nice example of dependencies in a cake making project. When the cake is being baked, we can make the icing. So this is a start to start dependency. After the cake is baked, we can start decorating it. That's a finish to start. Or cake decorating has to finish before we deliver the cake. This is a finish to finish dependency. As shown with some overlap of the two tasks, it suggests that some decoration may be occurring while the cake is being delivered to the customer. And finally, the customer bill has to be finished by the time we start the delivery of the cake. This dependency is start to finish dependency. Dependencies can also be categorized as mandatory or discretionary. Mandatory meaning that it has to be in place before some other tasks can be performed, such as requirements need to be in place before programming can be done. Discretionary, on the other hand, means that they are by choice of the project manager or project sponsor, such as adhering to a particular software architecture, like web services. That's a discretionary dependency. Another way to categorize dependencies would be based on them being external or internal to the project. An external event or project such as hardware upgrade in the data center. If our activities depend on that, that's an external dependency. An activity within the project, such as the dependency of, say, testing on programming, that's an internal dependencies. So we cannot test if new code or module is not developed or is not in place. So that would be an internal dependency that we have in the project. In addition to dependencies, the dependency between two activities may contain a lead time, that is the time that the start of the successor activity, the second activity, can start before the completion of the predecessor activity, the first activity. For example, the amount of time that the testing can start before the completion of programming, that is called the lead time associated with that dependency. In other cases, there may be a lag time, and this is the time between the completion of the successor activity and the start of the successor activity. After we have identified activities, their attributes, their dependencies, we can visually present them in an arrow diagram. In this method, the nodes designate the start or the end of an activity, and the arrow represents the activities. The duration is shown next to each activity. So in this example, activity A has the duration of 2 days. Another way of showing the activities, their attributes and dependencies, is through a network diagram. Again, Microsoft Project can generate these visual representations very easily after you set up your project on Microsoft Project. This concludes my lecture on schedule. I hope you enjoyed learning about how a project can be broken down, the work breakdown structures, and then activities in each work package are identified, and their attributes, such as the time and resources required, are estimated. Then we establish the dependencies among the tasks, and finally, putting all that information together, we can produce the project schedule, which we can display in many different ways depending on the audience with whom we are trying to communicate. Thank you very much, and I'll talk to you later.